Hi there, I'm Tim Bruening. I'm one of the faculty at LCCC's Fab Lab. And what we're looking at here is a laser cutting machine, a laser cutting or engraving. And what we're going to produce right now is a little box out of a piece of paper. You can take a flat piece of paper, and as you cut it, we're doing a dot pattern, so we can end up folding it, and the little box will come together, and then you do a little bit of gluing here, and then you end up with a little 3D box that you can use for party favors or something like that. All we do is get everything set up here. We have the file has already been sent from the computer, and we come over here and we hit go, and now you can see the laser cutting. Right now it's cutting a dotted pattern, so that way it's not going to fall apart, but we can fold along that line. So it'll do all the dotted lines first. Now it's doing a little cutout. Okay, now it's cutting the entire piece out. And there it is. That's how you cut a little fold-up box out of a piece of paper on the laser. Hi, Tim Bruening again, LCC Fab Lab. What we have set up on the table here is an array of different pieces, parts that you can manufacture at the LCC Fab Lab. One of the things we have here is called a vinyl cutter machine, and if you want to just roll over to the door, you can see that here. This is a vinyl cutter machine. It has a programmed razor blade, and what we can do is cut out vinyl that's self-stick. We can cut out the letters. To keep the letters, we would throw away everything on the outside. Or we can make a stencil that you could put on a t-shirt or whatever for screen printing, you know, whatever you want, and you can make a stencil, so a couple different things. Another material that we have available, this is a self-stick copper material, and what we do is we cut out circuits. So the razor blade would come in there, and it can cut out the circuit, and then we would have surface mount technology where we can solder some fittings. You can make some pretty complex things. We also have the ability here to do a little bit of CNC machining with a small machine. We would start with a copper-infused plastic plate, and what we do is we machine all the parts that we don't want copper. What we leave now becomes the traces that the electricity would follow through, and we have some surface mount electronics here, and this particular circuit just has a bunch of blinky lights, but it is run by a small computer chip. This is a purely vinyl piece, and the way they do that is every single color here is a separate cutout on the vinyl, and you have to start with whichever is your back color. You put that down, and then you layer as you're going with your different colors. And you can get quite complex. This is parts that are cut on the laser. We have here at the college a Project Lead the Way group. They're high school students that were interested in getting into science. And this is something, they cut out these little pieces and make these trusses. And they have a piece of equipment, and then they'll go through and they'll do a stress test on these and break them, and then they get in there and they change their design a little bit, and they start experimenting and going through different iterations to find out what different pieces, parts are better in whatever shape and angle. This is something that would come off of our CNC routing machine that we would use to cut the circuits. We can cut 3D parts on there and either make the finished shape. This is a piece of foam material. And what we could do is pour in some type of an epoxy, and we can make a mold, and then from that mold we can make more parts from it. Looking at the molding technology, while we're on that, this is a mold that was cut on our larger CNC machine out in the shop. It's called a shop bot, and this wax was used because it's very easy to machine, easy on the tooling, and as we cut the wax out, we make a mold to make a mold. This is a urethane plastic which is poured into there and allowed to set. And when that comes out, we can now take whatever material we have. In this case here, it's plaster. We have different other epoxy resins that we can use. And then now this can be used to make as many pieces, parts as you want. And if you have a lot of production you want to make, you can make a couple of these, so then you can get into making things. The nice thing about the flexible mold is it's easier to pop the parts out. Because if you had a rigid mold, sometimes it's tough to get the materials out depending on your draft angles, that type of stuff. Here's some different pieces of material that were cut on the laser. This is actually a form of cutting. This is not a bent piece. This is, that was formed by heat. This was formed by all the cuts and it made it flexible. So after those cuts were in there, we took the part and rotated it, and they had end caps made for it. You can also do that with a piece of wood. You can make like a book jacket out of wood by doing that. This is just simple engraving, to where you can take a picture. You could print this from CorelDRAW software. You can print it from Word. All it does is the laser is going to go back and forth like the old dot matrix printers, and every place there's a dot, it's going to burn it. This is another example of that. This particular piece here is leather. This is a little piece here to make a coaster. Again, I personally made about, I don't know, 50 of these a few years ago for Christmas presents, that type of stuff. You can get a two-part material plastic. In this case here, the majority of the material is white with an orange coating, and what you're doing is burning through the orange, showing the white behind it. And this was just a little medallion that somebody was making for the MS Walk. These are pieces that we use with the students. We take your original letters, just again in CorelDRAW, you type them in, and then we have an offset command, and what happens is we take those letters and offset them, and then we sort of blend them together, and then we just cut them out of foam, and then that way you have a backing, you know, with a nice label for that. These are different pieces, parts of plastic that are cut. This is acrylic plastic. All right, we can make little boxes of that again. We can cut up to about 1/4 inch thick acrylic, about 1/4 inch thick wood, you know, typically plywood, that type of stuff. There are some materials that are a little tougher to cut than others, depending on the species of the wood, you know, that type of stuff. Here's something called a Tanagram. They use these in schools a lot, where you give people shapes. Okay, get them out. Yeah, gotta be a way. And then you can take these and then you can start building different shapes like a house. It's a game that you can buy. And this is something one of the students made. Here's a little one out of multiple layers. I don't know if you can see it that well, but it's a little impeller, a little pump. It is going around, it'll pump water out. So somebody made that just out of a piece of acrylic and a bolt. This is a little 3D puzzle. Again, in this case here, this is made out of mirror. It's plastic mirror. You can cut it with the laser, so you can make a mirror any shape you want. And in this case here, we lasered the material off the back of the mirror and then painted it. All right, but it shows up real neat on the other side where we had cut through. You can do some really, really interesting things. We do have a few pictures around the lab where we've done that with regular glass mirrors. You engrave the back, and then you spray paint them black to bring out all the detail. You can do nice stuff here. Here's a little marble game somebody made. Oop. This is something we made here. This is inlaying with the laser. You just make a basic shape that's the shape of your frame, lay out where you want your letters, and you do an engraving to where you burn into it. All right, and then you take those letters and turn them into an outline, and then you cut it out of a contrasting color of wood, glue it in, sand it down, and then you have yourself a nice inlay. These are very nice to do here. We do a lot of large prototype work with larger machines, and this is just a small prototype that we did to check out and see if it works and everything, all the technology and the ideas, and then we build larger pieces than this. We can show you that one later on, but we make a small sample before we make the large one. This is just another different piece of two-part plastic, and it's more of a bronze coating on the outside. You see these a lot of places, people make name tags out of them. In this particular case, they did that, but then we have a bending machine here. We set it up, soften a little bit, and you just put it over on the edge of a table and bend it, you know, something like that. So different things you can do there. These are some parts that were made on our 3D printer. Originally, people would call this a rapid prototype machine. Nowadays, they actually call it rapid manufacture. A couple of different pieces, parts we have. Our machine didn't make this, but this is one thing we can make on machines. It's a wax model. We can take this and take it and make a ceramic mold out of it, burn that out in an oven, and then we can pour silver, gold, or whatever and make jewelry. Another thing that a lot of different places are getting into, there's an organization called Enable, and what they are working on is making prosthetics for children. And the big thing is, it would cost $10,000 approximately to buy this, going through the regular medical profession. Typically the organizations that are volunteering their time and materials can make something like this for like $80, so it really helps out with people. And especially when you're looking at children, children grow, you know, so you have to have different ones of these as they get larger, you know, so these are different things. And again, this is 3D printing technology. What we do is we use ABS plus plastic, and this material, the best way I can describe it is weed whacker string going through a hot melt glue gun, and it's going to go in and it's going to do a layer about 10,000ths of an inch thick, 0.010, goes up, makes a layer, and it keeps building and building and building until you have the final finished part. This was actually built all at the same time together as an assembly. Okay, it had some material inside that would hold the pieces together. After we're done, we would throw it into a tank, and then we can dissolve that support material. How about I show you the 3D printer where we make these. Oh, this is our 3D printer. This is a Dimension SST20 or 1200 ES. The ES, our SST stands for Soluble Support Technology. It means the material will be dissolved in a tank later on. Other machines, you would have a breakaway technology. What this particular machine does, we have an environment in here that's heated, it's warmed up, and we have a 10 by 10 by 12 inch area. That's the size of our build. And what we can do, there's a plate here, and that plate keeps moving down whatever your resolution, whatever the thickness of your layer is. Right now, this particular part is being built at 0.010 thickness. So it does a layer, moves down, does another layer, plate moves down, the actual head itself remains at the same height. And when you're doing these different parts here, some of these parts, to make one to fill that entire build area, may take upwards of a day and a half to 2 days. It's not a real fast process. But if you would look at what it would take to make a mold to then go to an injection molding machine to make these parts, you're talking months. So we're taking months of work down into days of work. Works pretty good. You'll see the head moving around, and it's a little tough because we have basically a black part. Right now the head's being cleaned a little bit. Now it's coming back. There's a little tower. What it's building right now is a rook, a chest rook, and it's only about 2 inches tall, and it's hollow on the inside, and it actually has a circular stairway on the inside of it. All right, you just saw a video of the 3D printer. This is the part that was being made in there. The one, you know, a little bit tough to see in there, but you can see this is a chest piece, and as you look at it, you can see quite a bit of detail going down from the top. There's a spiral staircase. There's no way this part could be cast in conventional means. The only way we can do this is through some kind of an additive manufacturing format. All right, you've seen some different shots of the Fab Lab here at Lorain County Community College. One of the nice things about this lab is that it's open to the public. Right now we're open on Mondays and Saturdays. Monday from 10 to 7, Saturday from 9 to 2. You normally would bring your own materials in, maybe some acrylic, plastic, some wood. We don't allow anything like vinyl. It turns into nasty gases and voids your warranty on the laser. But it is free for you to use. If you want to come in without taking a class, you can do that. We have a lab aide here that would help you. But we do also recommend that you take a regular 1-credit course here called Introduction to Personal Fabrication. It usually runs about the 5th week of the semester to the end of the semester. It's 10 weeks, 1 day a week, hour lecture, about an hour and 15 minutes while working on the lab projects. And what we do is we teach you the different software packages and the machinery that are located in the Fab Lab, so then you'll have a much, much better experience when you come in to try and make things. Thank you very much.